This semester, our team, consisting of Patrick McSpadden, Corey Flavin, and Evan Lombardo, worked with the Nature Conservancy to come up with a solution for mass productions of seed pellets. Let me take you back now to the origin of the problem and how our project fits into the larger solution. Each year, we lose roughly 15 billion trees to fire, disease, and deforestation. And these problems are only getting worse in recent years. This is a significant issue for two reasons. First, when a tree burns or is cut down, it releases its stored CO2 into the atmosphere. And second, it can no longer continue to capture carbon from the atmosphere. In order to mitigate these effects, we need to do vast amounts of reforestation. The challenge is this has generally been done by hand, by planting seedlings or by dropping seed pellets throughout areas. This is challenging for a few reasons. First, it's labor intensive. Second, it takes quite a bit of time. And third, it's very difficult to reach certain geographic areas. The modern solution to all of this is to use drones for reforestation, to drop seed pellets in hard to reach areas that then can grow into trees.
The problem with using drones to reforest large burn areas is being able to efficiently produce enough seed balls to meet the high demand for reforestation. Typically, people make seed balls by hand, rolling each seed ball one by one. This process is slow, messy, and labor-intensive, so we sought to make a machine to expedite and automate this process. We wanted to create an inexpensive, easy-to-use device that could produce hundreds of high-quality seed balls every hour that had a high rate of germination. We developed several prototypes with a 3D printer. Our last prototype produced 25 1-inch by 1-inch seed balls very easily and consistently, but due to extraneous circumstances, we could not build our final model.
In our final design, we wanted to increase seed pellet production as much as possible while reducing complexity as much as possible. Thus, we went with this super simple extruder type design, equipped with a hopper in which dirt can be loaded to do multiple batches and a cutting system to easily form the seed pellets. As you can see, dirt is loaded through the top and with the help of a mechanical press is pressed through the bottom, where it is formed into perfectly square seed pellets. This bottom tray can be slid in and out to help cut off the seed pellets from the bottom to drop them into the tray. The way we introduce seeds to the tray is with the help of this silicone piece with cavities in it just the size of ponderosa pine tree seeds. This mold is then placed on top of the tray pre-filled with dirt, and the seeds are released onto the top of the dirt, where they will stay and be reinserted into the machine. Then more dirt is extruded over top and another batch of 50 seed pellets is made. As it can be seen, this machine has huge implications on speeding up seed pellet production and thus helping us catch up with reforesting Colorado.
In summary, our tool is simple to manufacture, easy to use by a single operator, wash down, and no power is needed. The cost is only $89 per unit to manufacture, and it's made out of basic materials like aluminum, silicon, and carbon reinforced filament. Most importantly, this tool significantly boosts production capacity. By hand, a single person can make 300 pellets per hour. With our tool, a single person can do roughly 2 cycles per minute, which translates to 5,880 pellets per hour, which is almost 20 times that which they could do by hand. We are very excited by the potential to have a positive impact on reforestation and hope to be able to manufacture it someday once the facilities at CU reopen.